Friends, welcome to Susan and John MathTube. In this video, we are going to discuss about Clairaut's equation. Basically, Clairaut's equation is an equation solvable for y. That is, an equation which can be written in the form y is equal to p into x plus some function in p. I'll repeat once more. It is an equation solvable in y. That means we can write y completely in terms of p and x. Second important thing, it should be and it must be in the form y is equal to p into x plus some function in p. You cannot change it. You cannot make it like y equal to minus p into x, or you cannot alter this part. It should be p into x, and the remaining part can be anything. It can be sine p, it can be p squared plus 5, it can be log p, it can be e to the power p. So basically the second part will be a function in p. Now if you have an equation solvable in y, I don't have to explain what next to do. You will differentiate with respect to x, you will try to factorize it, or you will try to make it into a linear equation, etc, etc. Now, do you remember what I told you in the last two videos? Whenever you get Clairaut's equation, you should always find the general solution and the singular solution. Let's start with an example. So please write, solve the differential equation p cube x minus p squared into y minus 1 equal to 0. So look at this. Since I saw this p squared and p cube here, I was sure that it will become what I call Clairaut's equation. So what I am doing is I am going to solve for y. So p squared into y, I am going to take it to the other side, is equal to p cube into x minus 1. Now y is equal to, I will divide throughout by p squared. So I will get p into x, see, minus 1 by p squared. Now are you able to see the Clairaut's equation? Y is equal to p into x and some function in p. Okay, now as usual, if you solve for y, we will be differentiating with respect to, differentiating with respect to, x. So we get dy by dx is equal to, we have to apply product rule here, p into 1 plus x into dp by dx minus, okay, now we have to differentiate 1 by p squared. 1 by p squared is actually p to the power minus 2. So when you differentiate, you end up with minus 2 p to the power minus 2 minus 1, and that will be minus 2 into 1 by p cube. So eventually you will get plus 2 by p cube. Okay, now what should we do in the next step? Yes, we have to replace our dy by dx with, by the way, we left one dp by dx, because when you are differentiating a function in p with respect to x, you should write the derivative multiplied by dp by dx. One good thing about Clairaut's equation is, in all Clairaut's problem, you'll see that this p getting cancelled with p. This p on the right and the p on the left will get cancelled. So you end up with dp by dx into x plus 2 by p cube equal to 0. So it's like very easy to factorize. And this happens in all Clairaut's problem. In all Clairaut's problem, you can expect that the factors, one factor will be dp by dx and other will be the one which gives you singular solution. So from the last video I was telling you, if the equation is Clairaut's, you should find singular solution in your syllabus. So this is going to give the general solution and this is going to give the singular solution. So I'll write for general solution and for singular solution. Here what will we do? dp by dx equal to 0, because you can see that a into b equal to 0. If a product equal to 0, then either a will be 0 or b will be 0. Now cross multiply, you'll get dp equal to 0. Integrating, we'll get p is a constant. Therefore, solution is, how do you write the solution? You go back. I forgot to keep equation number 1. You can put it here or you can put it here. So c cube into x minus c squared into y minus 1 equal to 0. I'm writing the like what you call implicit solution, not the parametric one. If you want the parametric one, you can put it here, etc., etc. But in Clairaut, you can write the implicit solution, because we will always get p equal to c. Okay, now comes the most important part, the singular solution. So look at this, the method is not going to change. Either you write x and y in terms of p, and that will be called the parametric solution, or you destroy p from the given equation, and that will be called implicit solution. Anyway, I'm going to give you two options. Number 1, parametric solution. So parametric solution means I'm going to find the value of x, and that is minus 2 by p cube. Then I'll go and plug it into equation number 1. So I get y is equal to p into, I'll show you what's that equation, px. So what is x? Minus 2 by p cube and minus 1 by p square. So that's it. This is a parametric solution. So x equal to minus 2 by p cube and y is equal to this will become minus 3 by p squared. So look at this. This is a well accepted solution. This is called parametric solution. But however, this seems like what you call, I can feel that I can eliminate that p and connect x and y. I can feel that I can eliminate y and connect x and y. If you can do that, then that solution will be called implicit solution. Just like this. See, x and y are connected and p has disappeared. So let's give it a try. So from the first equation, I can see that p cube equal to minus 2 by x. And from the second equation, or I'll do one thing, I'll take cube root. So p is equal to minus 2 to the power 1 by 3 by x to the power 1 by 3. Let's take this and put it in the given equation. Okay, now in the second, that is y value, we can see p squared. So I'll square on both sides. When you square a negative number, the number will become positive. So I get 2 to the power 2 by 3 by x to the power 2 by 3. Okay, now you have one more option, that is you can eliminate p. That is, we can connect x and y just like this. We can have the implicit solution. If you want, we can leave it as the parametric in the parametric form. But if you can, you go for the implicit solution. So what I'm going to do is, I'm going to remove y from these two equations. So from here, I'll get p cube. I'll get p cube is equal to minus 2 by x. So that p will be equal to minus 2 the whole power 1 by 3. I'm taking cube root, x to the power 1 by 3. And if I square, because I know that the given equation has square, so I'm squaring on both sides, and when you square any negative number or positive number, the number will be positive. So 2 to the power 1 by 3, 2 by 3, x to the power 2 by 3. Now where is the given equation? Y equal to, you can put it in the given equation, p cube x. So p cube is minus 2 by x into x minus p squared into y. So p squared is 2 to the power 2 by 3 by x to the power 2 by 3 into y minus 1 equal to 0. So these two get cancelled. So we end up with 2 to the power 2 by 3 by x to the power 2 by 3 is equal to minus 3. Now you can take cube on both sides. You can cube both sides. So the whole cube will be 4. Again cube, so that will be x square is equal to cube, that will be minus 27. This equation looks like really good. I left one y here, so we can multiply by y. So we end up with, so there should be cube. So we end up with 4y cube equal to minus 27 x square. So if you want, you can write the solution like this or like this. Let's go for another question. Y is equal to px plus a by p. Now look at this. This is 100% Clairaut's. You can see p into x. Now the remaining is a function in p. There is no x, there is no y. Okay. So as always, in an equation solvable for x, you will differentiate with respect to y, and in an equation solvable for y, you will differentiate with respect to x. So Clairaut's equation being an equation solvable for y, we differentiate with respect to x. So dy by dx will be p into 1 plus x into dp by dx plus a by p. A by p means a into 1 by p, and the derivative will be a into minus 1 by p square. Don't forget, the derivative of 1 by x is minus 1 by x squared. So we get this plus will become minus a by p square into dp by dx. Now look at this. What will we do with dy by dx? That will be replaced with p. And like I told you before, in every Clairaut's equation, this p and p is going to get cancelled. So we get dp by dx times x minus a by p square is equal to 0. See, now we are able to factorize. So this is going to give you general solution, and this is going to give you singular solution. So I'll write, for general solution, use the factor that contains dp by dx. For singular solution, use the factor that do not contain dp by dx. And in Clairaut's, you have to evaluate both. So dp equal to 0, so p equal to c. All you have to do is you have to put it in the given equation. So that means the general solution is y is equal to cx plus a by c. Now comes the other part. So we have x equal to a by p squared, and I'll put it in that y. So we get y is equal to p into x. So that will be p into a by p square plus a by p. So I get x equal to a by p square, and y is equal to 2 into a by p. See, this is an answer. This is an well accepted answer. This is called parametric solution. We are writing x and y in terms of p, so it is called parametric solution. But here it looks so simple. I know I can eliminate p very easily. So what I'm going to do is I'm going to square the second one because I want to eliminate p. So x equal to a by p square, y is equal to 4a square by p square. I'm squaring, so y square equal to. Now you can divide, or you can find the value of p square from the first one, put it in the second one, somehow eliminate. So from the first one, p square is a by x, and I can put it here. So I'll get y square equal to 4 into a square into x by a. So I end up with y square equal to 4ax. So this is called the implicit solution. Yeah. Anyway, let's go for another question. Okay, write the third question. Solve the differential equation p is equal to log of px minus y. Point number 1, you have to be aware that whenever we write log x, according to your books, because actually in calculus we should write ln x, the natural logarithm of x, but most of your books, even in the question papers, they are following log x in calculus under the assumption the base is e. Anyway, when you have log x equal to something and you want to find the value of y, x, look at this. Suppose I have sin x equal to t. So if I ask you what is x, you will tell me it is sin inverse t. Similarly, I want to write log inverse y. But wait a minute, I have never seen such a notation. What is this log inverse? Exponential. So to be aware of this fact. Okay, so look at this. Here I want to take log inverse. But what is the inverse of logarithm? If the base is e, e to the power. So I get px minus y equal to e to the power p. So y is equal to px minus e to the power p. Wow, that's it. So this is Clairaut's equation. The remaining you can do very easily. I'll show a few steps. So what should we do? dy by dx equal to p into 1 plus x into dp by dx minus derivative of e power p is e power p into dp by dx, because we are differentiating with respect to x. Now this is p and p will get cancelled. As always, dp by dx into x minus e power p equal to 0. So we get either dp by dx equal to 0 and x equal to e power p. So this gives we have done so many problems. P equal to c, plug it into the given equation, you'll get the general solution. Now this is so easy. We already know x value. You plug it here. So we get y is equal to p e power p minus e power p. If you want, you can leave it here. If you want, you can leave it here. This is the parametric solution. But if you want to get rid of p, it is very easy. Come on, read from right to left. E power p is x. So the solution is given by, the singular solution is given by y is equal to px minus x. So look at this, read from right to left. We can have p is equal to log x. So all you have to do is you have to plug this here. So we get y is equal to log x and e power p will become x minus x. Okay, now let's do one more problem. Let's discuss one more problem and that's it. So x minus a into p square plus x minus y into p minus y equal to 0. So if you simplify this, I'm going to simplify this, x minus a into p square plus xp minus yp minus y equal to 0. So x minus a into p square minus x plus xp. I'm going to take this y common because we need y in terms of x. So y into p plus 1 is equal to, I'll just open the bracket, x into p square minus a into p square plus xp. Okay, now I can see Clairaut slowly popping up. Y into p plus 1 is equal to px plus p square x minus a p square. So y into p plus 1 is equal to p x into p plus 1 is 1 plus p minus a p square. Okay, that's it. Divide throughout by p plus 1. We get y is equal to px minus a p square by p plus 1. I'll show one more step and stop. So can you see this is Clairaut's equation? So you differentiate. So dy by dx equal to p into 1 plus x into dp by dx minus, we have to apply u by v rule. So denominator into 2p dp by dx minus numerator and dp by dx the whole divided by p plus 1 the whole square. Now as always these two will get cancelled and you'll be able to find the x value, and you'll be able to write x and y in terms of p very easily. And if you can eliminate p between them, and you'll get the implicit solution. So that's it. I'll be back with another video very soon. So till then, my friends, bye.